Hello everyone, I am Anand, new faculty at Department of Mathematics, Tunga School of Basic and Applied Sciences, M-2. From now onwards, I will be handling paper 2 of B.Sc 5th semester, that is numerical analysis. So already bisection method have been discussed by sir. I am going to continue with the another method, iteration method. So iteration method is helpful in finding the value of the root of the given function f of x is equal to 0. So let us see what is the iteration method is. Suppose we want to the approximate root of the equation f of x is equal to 0. Now we are going to write this equation 1, that is f of x equal to 0, in the form of x is equal to phi of x. Assuming x0 is the starting approximate value, so we replace x by x0 in the RHS of 2, then we get the first iteration. Using setting x is equal to x0 here. Okay. So then we get the first iteration x1 is equal to phi of x0. The second iteration x2 equal to phi of x1. Next third iteration x3 equal to phi of x2, and so on. Then the nth iteration. Suppose if you, while doing a problem, if you get some the fifth iteration and the sixth iteration, both are same value with a certain decimal points, say up to 4 decimal points, then we say that this is the root, 6 is the root, because we got the two iterations, the same value. Okay. The sequence of approximate roots x1, x2, so on, xn, if it converges to R, that means if xn is very close to R, then we say that this xn is root of the equation f of x equal to 0. So this is the iteration method, and describe briefly iteration method is asked for 2 marks in the semester examination. Then you have to write this all for 2 marks. So very simple, the given function f of x equal to 0, write it in the form of x equal to phi of x. Now assume x0 is the starting approximate value of the root. Setting x equal to x0 in the RHS of 2, we get the first approximation, second approximation, third, and so on, nth approximation. If xn is very close to R, then we say that xn is the approximate root of the equation. So this is very simple method, but this method has one condition extra, so that is condition for convergence. That means whenever we take x is equal to phi of x, we don't know from where, which initial point, we don't know what is the initial point, then we need to check this condition, mod phi dash of x is less than 1. Okay? So that is, let f of x equal to 0 be given equation whose actual root is R. The equation f of x equal to 0 can be written as x equal to phi of x. So now let I be the interval containing the root x is equal to R if mod phi dash of x is less than 1. That is differentiation of phi of x, its absolute value, is less than 1 for all x in the interval, then the sequence of approximations x1, x2, so on, xn will converge to R. Okay? That means we need to choose the initial value very close to the real root in order to get the convergence. That's what the meaning. Okay. So say suppose I have a function f of x is equal to cos x minus 3x, then we can write this as x is equal to 1 by 3 cos x. So this is taken as phi of x, for example. Okay. Yes. Now let us see how to solve a problem using iteration method. For that, we are given some algorithm. In the first step, given function f of x, we have to write it as x equal to phi of x. So by trial and error, find the interval in which the actual root lies. So that is x naught by using the intermediate value theorem. What is intermediate value theorem? Suppose f is a continuous function in the interval a comma b, then f of a, if f of a into f of b is less than 0, then there exists at least one root that belongs to the closed interval a comma b. Okay? This is the intermediate value theorem. So that, let me repeat it again. If f is a continuous function in the closed interval a comma b, and f of a into f of b is less than 0, then there exists a root r in the interval a comma b. Okay. So now check phi dash of not x naught, phi dash of x. Mod phi dash of x is less than 1 for all x, not only one x, for all x that belongs to the closed interval a comma b. So now start iteration process. Taking x naught as an initial root, find x1, next x2, so on. Repeat this step until you get an root, approximate root. That is the value of this very close to the root. So let us see this an example. Okay. So find the real root of the equation cos x equal to 3x minus 1 corrected to 4 decimal places by iteration method, not iteration method. Okay. So now let us see the solution. So let f of x is equal to cos x minus 3x plus 1. So this I have taken this side. So this is equal to 0. Okay. So now by trial and error, see f of 0 is 2. This cos 0 is 1, 1 plus 1 is 2, and this is 0, which is positive. Okay. So since this is a transcendental equation, you have to use calculator in the radian mode. So let me check f of pi by 2. Cos pi by 2 is 0, and this is 1 minus 3 pi. So 1 minus 3 pi by 2, this will be always negative, because 1 minus 1.5, this is always negative. This is less than 0. Okay. Yeah. So that means I came to know that there exists at least one root in the interval. So the root exists in the interval 0 comma pi by. So therefore, I am going to write the given function in the form of x is equal to phi of x. So that is x is equal to 1 by 3 to 1 plus cos x. So this is, I am going to take it as phi of x. Okay. So also check phi dash of x. Phi dash of x. Phi dash of x is minus 1 by 3 sin x, and mod phi dash of x will be mod sin x by 3. So we know that mod sin x is less than or equal to 1. Sin x by 3 will be obviously less than 1. So therefore, start initial approximation with all conditions are satisfied. So start with x is equal to, no, sorry, x naught equal to 0.6. Start with x naught equal to 0.6. Then we have x1 is equal to pi of x naught, which is equal to this pi of x naught. Pi of x is 1 by 3, 1 plus cos 0.6, because x naught we have taken 0.6. Okay, so this is 0.6. So keeping the scientific calculator in the radian mode gives you 0.60845. This is what? 0.60845. Please check in your calculator. So now taking x1 as 0.60845, I am going to calculate x2, that is pi of x1. So that is 1 by 3 of 1 plus cos 0.60845. So this gives you 0.60684. Okay. So similarly x3, that is pi of x2. So replace x2 with x1 by x2 here because of 0.6084. So this gives you 0.60715. So now check x4, it is pi of x3. So repeats the same procedure. You get 0.60709, and x5, pi of x4. Okay, that is 0.60710. So next check x6, that is pi of x5. So that is equal to 0.60710. So we see that x5 and x6 are same. Okay, so then we can say that the real root of the equation is 0.60710, because the root has been converged here. So this is corrected to 4 decimal places. So we got the approximate root of the equation of x equal to 0. So that is r is equal to 0.60710. Is it clear? So let me explain the method once again. F of x is given, and we have to check see where the root lies by trial and error method. So the root lies between r and 0 to pi by 2. Pi by 2, why we have taken? Because it's cos x is a periodic function and it's transcendental function. So therefore we have taken 0 to pi by 2 values. So now x equal to pi of x we have written here. Okay. So we have to check the pi dash of x, that is differentiation of pi of x, that is 1 by 3 into differentiation of cos x is minus sin x. Mod pi dash of x, this is mod sin x by 3 is less than 1. To start initial approximation with the 0.6, we have iterated values x1, x2, x3, so on. Okay. Then we got the real value x6. Right. So this is, we shall continue the next examples in the next class. Thank you.